Here we are at example 8 looking at Here Sharky Sharky. Now I was watching Shark Week a little while ago and they were talking about this how they could actually take a tooth size and basically just from that determine how big a shark actually was. And that was actually, I thought, a really awesome experience where you could actually use direct variation to then see maybe how big an animal actually is. And so the question here is, well, if in fact, is this a form of direct variation, first of all? And if so, what is an equation that relates these quantities? Now, as we can see, we actually have several different tooth sizes and the corresponding body overall length that they should be. So I'm just going to randomly pick one. We'll just go with this 3.6 comma 430. So right there we actually have an x and y point, 3.6 comma 430. And again, since we don't necessarily know how big the shark is, we can go ahead though and use the tooth size though to kind of determine that. So that's in fact what's our x variable, and that's why our y variable is pretty much the length of the shark. So tooth size determines how long the shark is actually going to be. Now again, just taking out the calculator, we have our y is equal to, as we know using direct variation, y is equal to kx. Well, we know our y value, he's 430, is equal to some k that we don't know, but that's being multiplied by our x value, 3.6. And again, we can very much quickly find our k value, our constant variation, just by dividing that x variable over. So we end up then with k coming out to be equal to 430 divided by 3.6. So just using the calculator, that comes out to be about 119.4. Now again, this is all real data, by the way. Let's go ahead and choose maybe a different tooth. Randomly pulling, I'll just go with the 6.5 778. So 6.5 comma 778. And typically what I have my students do is I'll just give them like pairs. In their pairs, I'll just say figure out their k value. So we have a bunch of different students figuring out different k values with these two different x's and y's. Or I'm sorry, with all these different x's and y's. So hopefully they end up with similar k values. So we end up then with 778 is equal to some k times 6.5. Divide both sides by 6.5 to get k by himself. K then is equal to, throwing this in the calculator, we have 778 divided by 6.5. So it comes to about 119.69. And we notice that our k's are not identical, but they're pretty darn close. And when we're talking about actual real life figures, that's actually not that bad. So as a result, tooth size does determine body length for a shark. Now, the biggest thing as I was watching on this Shark Week was they found actually a fossil of a Megalodon tooth, and it was 20.83 centimeters. So if you're not familiar with what the Megalodon is, it's the biggest shark to ever kind of be known in existence, and we can only really determine its size just based off of their teeth. And that's really where direct variation starts to flourish. So again, using our k value that we know, we don't know how big the shark is, so he's y, but we can use our k value. Let's just go ahead and use like kind of in between here. So 119.5. We'll just go with that as a safe kind of average between these two. A lot of these other ones came out for a k as like 120 or 119, so they're definitely all right around there. But again, we know our x value, that tooth size, it's 20.83. When we go ahead and throw that in there, now we can just go ahead and use our calculator. So 119.5 times 20.83 equals 2,489. Point 185. And now this is in centimeters. If you were just to move that decimal over 2 places, you would see that it comes out to be about 24.89 meters. And that's a pretty big animal. I mean, 24, almost 25 meters long. That's huge when you factor in that you are about, I mean, close to maybe about 2 meters only. This thing's 25 meters long. So let's go ahead though and just look at a converter just to see in feet how big that is. So we have 2,489 point, it was like 1 something, 185. So this thing is 81 feet long. 81 feet long. That's insane. That is so huge. Almost 82 feet long for an animal. That's massive. So typically when we're talking about direct variation, I kind of actually go out into the hallway and show my students just how big that is, and it's pretty huge. I mean, that's a big animal that we're talking about. And then I also typically show this little short clip from the Shark Week, and so if you guys want to watch it, feel free. If not, you know, hey, that's up to you.
Miles inland from California's current coastline, a landscape of rolling hills shelters the densest concentration of Miocene marine fossils in the world. This bone bed was the hunting ground of Megalodon, the most fearsome creature ever to haunt the oceans. Today, this formation is commonly known as Sharktooth Hill.
15 million years ago, this place was a shallow marine sea, maybe 100 to 200 feet deep, full of all kinds of life, particularly vertebrate life. Sharks, marine mammals and fish, birds overhead. It would have been a lot like the Chesapeake Bay is today, but with much larger types of prey and predator. It would have been truly an amazing sight to see.
Megalodon, literally translated, means big tooth. And these 7-inch teeth are almost all that remain of this extraordinary creature. No skeletons have ever been found. What we do know is that Megalodon ruled the seas for some 25 million years, going extinct just under 2 million years ago. What they looked like, how big they were, how they lived, how they died, is a mystery science is only beginning to crack.
Megalodon was probably the apex predator of all time. People think T-Rex or something like that. It's dwarfed by Megalodon. Megalodon is huge, maybe even 70 feet long. T-Rex wouldn't have a chance against this thing. T-Rex's head would fit in this guy's mouth.
But how big was that mouth? How large a bite could it take? Unlike the T-Rex, which left many bones behind, the skeleton of a megalodon, like all sharks, was made of cartilage, and cartilage rarely fossilizes. All we have left of this enormous predator are a few saucer-sized vertebrae and teeth. But these teeth might be enough. By starting with just one, it might be possible to reverse engineer a nightmare. A nightmare we call Sharkzilla. The 25th anniversary of Shark.
So hopefully you guys enjoyed that short little video and this example, as it kind of really relates real life scenario stuff with, especially if you're thinking maybe like marine biology, with direct variation and some of the math that we actually see. So again, when they were talking about that reverse engineering, they were actually using that direct variation type of method to determine the size of this thing. So again though, that is example 8 from our 2.5 set of notes.